Welcome to the second lecture on GCF. Let's start by again recalling what a GCF is. So the greatest common factor, GCF, is the least power number and variable two expressions having common. Okay, it's the least power number and variable two expressions having common. All right, so let's start off with an example. Let's say you had 7x plus and 28. Right? So if you had 7x and 28, then we can factor the 7. 7 is just 7, doesn't break apart, and x is just x, doesn't break apart. However, the 28 we can write as 2 times 14, which is also even. That's 2 times 7. So that means this is equal to 2 squared times 7. So if I look for the GCF between these two, I notice that there is a 7 in common. That's it. So the GCF is going to be 7 to the first power, because that's the least powered number the two of them have in common. Okay, GCF is 7. Now, this is a example that I want us to study carefully. This simple example. Let's look at this problem. Factor 7x plus 28. Now this strangely is the same process, the same as what you did above. If you had to factor this, the first thing you want to do is find the GCF. First thing you want to do is find the GCF between 7x and 28. And so when we break this apart, we write this as 7x and we write 28 as 2 squared and 7. And then we say, okay, so the GCF is the 7. So we identify the GCF. We did all this in the previous, just right above in the previous example. So the GCF is 7. Now we didn't really pay much attention to what was left. So once we figured out the GCF for 7, notice that there are pieces left, right? So those two are left behind. So the way you factor this is you find the GCF and you find what's left, and then you write it with the GCF in the front multiplying into what's left. So in other words, you say 7x plus 28 is equal to, you have the GCF here, parentheses, and what's left there. And so in other words, we would have in our problem 7x plus 4. And you can see that what we have done is essentially unmultiply 7x plus 28. You can always check to see if we did this right by multiplying. So we can always distribute and check if this actually works. So we can take 7x plus 4, distribute it in, and get 7x and there, and get 28, and see that we've done the unmultiplication correctly. Right? So the answer to factor that is this, unmultiply is that. Now doing this first step actually is the most important thing to be able to do. Right? So let's try another one. Factor, and this time let's take 8w squared plus 12w to the 6. So let's find the GCF. Now as you get better at this, you'll be able to just look at this and pick the GCF. But with numbers it's hard. Right, so 8 I'm going to break as 2 and 4, and 4 breaks as 2 and 2. So really what I have here is 2 cubed w squared. And then the 12 I'm going to break as 2 and 6, and the 6 is 2 and 3. So this is really 2 squared 3w to the 6. Now remember what the GCF is. The GCF is the lowest power of the numbers and letters they have in common. So they certainly have a 2 in common, and so the lowest power of that would be that one. So the GCF is 2 to the second. And so what about W? Lowest power of numbers and letters they have in common. So there it is, that one. So W squared. Now, what is left behind? Well, over here, if I take 2 from this 3, I have 1, 2 left. And the W's, well, they were both accounted for. Now if I move on to this second expression, this was accounted for, but the 3 was not. And then the W, I've taken away 2, so it's going to be W4. Right? And again, you can check. So sorry, before we get to checking, let's actually multiply this out. So that's 4w squared and 2 plus 3w to the 4th. Now, you can always check to see if you did this right. So this is your answer. Make sure you highlight the answer before you do anything else. Now, you can always check to see if you did this right by distributing. So if you go 4w squared times 2, you get 8w squared. 4w squared times 3w to the 4, you get 12w to the 6th. Okay, so you have the pieces that are taken for the GCF and the pieces that are left behind. So if this left behind part's a little hard for you to see, you can, once you identify the GCF piece, you can think of this as 2 to the second times 2 and w to the second. So this then goes into the GCF, and then 2 to the second times 3, and then this would be w to the second, w to the 4th. So this and this and that are all GCF. That's the lowest power of everything that they have in common, right? And so you can sort of then see that the left behind stuff is this, right? So let's do one more GCF problem. So factor 3x squared plus x squared plus 9x squared y. So 3 doesn't break apart, that's it. X squared, x squared, x squared. This one here breaks, so it's 3 times 3. Okay, so let me 3x squared plus x squared plus 3 squared x squared y. Alright, so let's first find the GCF. So I look for a 3 across, there is no 3 across. So 3 is not in the GCF. How about an x? Well, there is an x here, an x here, and an x here. And the least power is 2 all the way across. So the GCF is x2. Okay, so that's it. That's the only thing they have in common all the way across. Now, if we were to take x2 away from that first expression, all I would have left is a 3. And if I were to take the x2 away from this expression, all I would have left is a 1. Right? You're sitting there going, 1? Where's the 1? Well, there is always a 1, right? 1. Plus, over here, well, if I took that x2 away, I'll have a 3 squared and a y. And yes, I can clean this up a little bit. 3 plus 1 after all is 4. And 3 squared is 9y. And there is your GCF. There is your factoring, not just GCF. We do one more of this factor, and this time we're going to take a look at a problem like this: 6y 5y minus 2 minus 5 5y minus 2. Okay, and so again I look for GCF first. That's the key, looking for the GCF. So 6, so we can get a little faster. You in your head you know that there are no numbers that divide 6 and 5, so there's going to be nothing in common there. there is no y in common either amongst these two, so the only thing they have in common is this, and so the highest power is a 1, so the GCF is 5y minus 2. That's the GCF. Okay. And so what's left? Well, what's left, it would be a 6y minus 5. That's the answer. 6y minus 5. Let's do one more of that type, because this is important, this particular kind, for the next set of factoring that we do. So factor, and this time we'll do 3x, x minus 3, minus 2, x minus 3. So again, I'm going to look to see if there's a 3 in common. No. Is there an x in common? No. Is there an x minus 3 in common? And yes, there is. So the GCF is x minus 3. And then what remains when you remove that x minus 3 would be a 3x minus 2. That's it. Again, if you were to multiply this, you would end up with the expression above in both cases.